So today's topic is RAID, redundant array of independent disk. Okay, here redundant array of independent disk, its name suggests that it has a series of disks. Okay, let's suppose we have 2 disks or 3 disks. They are all independent to each other. Why independent? Because what happens if one disk fails? The data in another disk will not depend on the failure of first disk. So that if one disk fails, the remaining data can be faced by the 2 disks. Okay. Now there are various types of RAID. According to your uses, you can choose any one. The first one is RAID level 0. RAID level 0 is also known as stripping. Okay. Now what is stripping? In this, what we have, let's suppose we have a data A. Okay. What we do, we just distribute this A into 3 categories: A1, A2, A3. Let's suppose we have data B, C, and D also. Then A1, B1, C1, and D1. Here we have A2, B2, C2, and D2. Here we have A3, B3, C3, and D3. Okay. Now what happened? The A1, A2, A3, these are all stripped data. It means divided data of A. B1, B2, B3 are divided data of B. When we add these two, A1, A2, A3, it will become A. Okay. That's how this will work. We will strip the data into 3 disks. Now what happened? If we want to read A1, we can read A1. We want to read A2, we can read and write both A2. We want to read A3, we can read or write A3. Before the stripping, what will happen? If we want to read A1 and A2 both at a time, we cannot read because it is a part of A, and we cannot access this with 2 processes. Okay, we can access this only by using one process. Okay. Now our second level is mainly this level, RAID level 1 or 0 is stripping. We only use to increase, okay, to increase read and write speed of data. Okay, this has 0 fault tolerance. Okay, this has 0 or no fault tolerance. Now our second level is RAID level 1, also known as mirroring. Okay. Now what happened in RAID level 0? We can increase the speed, but what about the security? There should be no data loss. As of now, in today's scenario, we have all things based on data. Data is the supreme power. So we have to secure our data so that no data can be lost in any disk failure. So we use RAID level 1, which is known as mirroring. What we will do in this, let's suppose we have a data A, B, C, and D. Okay, we have this 4 data A, B, C, D. Now in mirroring, what we will do, we will have A, B, C, and D, and it's a mirror copy A, B, C, and D. Now what it gives security. Okay, read write speed is average, but it gives security or fault tolerance. Okay. Now many of you think what will happen if we combine both RAID level 0 and RAID level 1. When we combine both RAID level 0 and RAID level 1, it becomes RAID 10. Okay, as the name suggests, this is combination of RAID 0, which is stripping, and RAID 1, which is mirroring. Okay. Now it has both good or increased read and write speed, and have fault tolerance. Now our third level is RAID level 5, which is known as parity. Okay. In this, what we will do, let's suppose we will have a data of A, B, C, and D. Then what we will do, we will store A, A1, A2, A3, B1, B2, B3, C1, C2, C3, D1, D2, D3, and we will have a parity section P. Okay, which have parity P1, P2, P3, and P4. This is when a parity is in the separate, okay, disk, then it is known as RAID level 4. And when we will combine these parities in the same disk, just like this is RAID level 5. Okay, when you combine this as A1, A2, A3, so A1, B1, C1, D1, and P2. Okay, A2, B2, C2, D2, and P1, A3, B3, C3, D3, and P3. And suppose we will distribute each parity in a disk, in separated disk, so that what will happen in this, if a parity disk is lost or corrupted, the overall we cannot have a recoverable schedule. Now in this, if one disk fails, we can recover this by using these 2 parities at least. Now what will happen? You have a question in your mind, then what will happen if 2 data is lost, A1 and A2 is lost? Then what happens? Then this parity will not work. So to solve this problem, we have RAID level 6. Okay, this what RAID level 6 does. Okay, RAID level 6 gives you a betterment of RAID level 5. It has 2 parity, so that if 2 data is lost, we can recover it. Okay, it has A1, A2, A1, B1, A2, B2, and it has parity P1. Okay, P1 and T1. Here we have P2 and T2. Let's suppose we have two parity P1 and T1, P2 and T2. Now what happen if we lose two data? Okay, we can also gain that back by using these two parities. Okay, these are the advantage of levels RAID level 6. These are all RAID levels of parity. I thought that you all understand well. Thank you.